a little bit. Okay, so you don't need to write this down. Let's just talk about what we know. So far we know we've been talking about exponential stuff and log. So this is an exponential equation and this is a log equation. Okay, so I'm going to use an example with a 2 in it. Okay, so that is how they would look different, exponential versus log. So let's say that I use an x value of 3. What's the result there? 8. So the coordinate would be 3, 8. Okay, so the input is the exponent and the output is the result. Okay, what if I was to do the same thing with the log equation? Does this make sense that I'd have to write it log 2 8 equals 3? Does that make sense? Because this is always the base, this is always the result, and this is the exponent. Okay, what happened to our letters? The exponent is which letter, X or Y? It's in the Y spot. Okay, so what happened? What's the difference between this and this? Does anybody remember that relationship that we learned in Unit 2 with our transformations? I think I heard it. Confident. Started with an I. Inverse. So an exponential function and a log function are inverses of each other. So what does inverse mean? If an exponential function will have xy, the log will have the coordinate yx. Okay? So with log functions, our equals is always, we're trying to equal the exponent, right? Versus on an exponential equation, when you're equaling, it's the result. Okay, do you remember the quick picture of what does an exponential equation look like when you graph it? What's always a point, no matter what? Before transformations, what's a point that we would have? 0, 1. If our base was larger than 1, we looked like that. And if our base was less than 1, we looked like that. Okay, so those are some things we've talked about already. Okay, so let's talk about graphing now. Okay, so here's the page in our notes where we stopped. Okay, so let's graph y equals 3 to the x here. We're going to graph it on this one. So y equals 3 to the x. Okay, so I always went like this. I kind of picked 3 coordinates to start with. What is 3 to the negative 1? What does it give us? 1/3. 3 to the 0, 1. 3 to the 1, 3. so if I graph it, what does my equation look like? What would be my next coordinate moving right? What's my next whole coordinate here? 2, 9, right? Okay, so what's the anchor coordinate? So the anchor coordinate was 0, 1. What's the equation of the asymptote? What's this equation? Y equals 0, because it's a flat height of 0. And what was the another point? 1, 3. Because you can always go 1, base, right? Okay, so what kind of coordinates are going to be on our log graph? So how will 0, 1 become on a log graph? 1, 0. If this has an asymptote of y equals 0, this will have an asymptote of x equals 0. Everything is u switching x and y. So this will now have a coordinate of 3, 1. Okay, so there's that. 1, 0. There's 3, 1. Here's the asymptote. If you want a third point, what's the coordinate of this third point? 1/3, -1. 1/3, -1. Can you see the shape? It's going to go like that and that. Okay, do you remember when you did an inverse? It reflects over that diagonal line. Can you visually see? Do you see a reflection? If I was to visualize that reflecting over that diagonal line, does that look right? Okay, what is the domain and range of this exponential? How far left, how far right does that graph move? Did you pick -infinity to infinity? It's going left, it's going right. What's the range? What's the lowest y height to the highest y height? 0 to infinity. And what kind of bracket would you put on that 0? Square or round? Round, because it's never hitting exactly 0. It's at about 0. Okay, what do you think about the domain and range of this log? The domain goes from how far left to how far right? 0 to infinity. And the range goes down forever, up forever. So what do you notice about the relationships of that? When we talk about inverse functions, the domain of one should be the range of the other, right? Because the domain is all the x of this, which in turn would be all the y's of that one. Okay, let's graph this. Okay, so the base is 5. So let's go 5 to the -1, 5 to the 0, 5 to the 1. Okay, so this is 1/5, this is 1, this is 5. So this is a log graph So how do I write the coordinate? 1/5 comma -1, right? Because it's opposite of how we were writing our exponentials. So this would be 1, 0 and 5, 1. Okay, so that's the basic. You don't have to graph that, but I just want you to see the basic. Because we're going to do some transformations to this. Okay, I had it step by step, but let's just go right to the end here. What is this? A, B, C, or D? That's an A, and this is a C. Okay, what is the shift on that with the C? Where does that go? Left or right? It goes right to. So where do you think my asymptote will be if the asymptote has to shift right to? So my asymptote will be at x equals 2. Okay. So I said instead of doing one thing at a time, let's just do everything together here. X plus 2 negative y. Does that make sense? X plus 2 negative y, because that's my C and that's my A. Can you change those 3 points? Okay, here we go. Here's our fraction. What is 1/5 plus 2? 2 and 1/5. What's the negative of -1? Positive 1. 1, 0 is going to turn into 3, 0. And the 5 is going to turn into 7. And then it's going to be -1. Okay, so you're going to plot those 3 points, and let's see if it makes those things in our mind of the reflection and the shifting. Okay, so did you see that reflection? And then did you see it move to the right? Does it look like it would do those things? Okay. Next one. We have some weird stuff going on in here. First of all, there's no base number. So what do I do on this if there's no base? What's the secret base that they're using? 10. Okay, so some original points. So I'm going to do that. I like to do those 3, usually no matter what. That's kind of my basis. So this is a log. So you do this for exponents and logs, but your coordinates are going to be flipped of each other. So if this is a log, I have a 10th, comma -1, 1, 0, and 10, 1. Okay, so that would be the original graph. Okay, this is pretty flat because it's 10, 1. Okay, well, let's talk about transformations here. I don't like the way this is written. How would I like to change the looks of it? Why don't I like it? What's wrong with its format? It needs to be factored out. So now x, and now a -4 as well. Okay, now we can talk about what happened. So what kinds of letters do I have here? This is a B, and this is a C. So I'm going to go x divided by -1 plus 4, and then there's nothing to do with the y's. Okay? Remember all that ABCD stuff. Let's talk about our asymptote. Where is our asymptote going to be? Is it still where it is, or did it get moved? Did our asymptote shift? Yeah, it shifted right 4. So our asymptote will be over there. Okay, so let's list the 3 points we made. Okay, so I just wrote the y's there because the y's didn't change. Okay, ready? -1/10 plus 4 should be 3 9/10. -1 plus 4 is 3. -10 plus 4 is -6. So there's my final graph. Okay, I see that reflection, right? It flipped across the y-axis, and then it also shifted right 4. So I can see those things. Okay, one more and then we're done. Okay, when we see ln, the ln is called the natural log. That's why it's an ln, natural log. So on these ones, do you remember what the secret base was? It's not 10, the ln. Do you remember that one? It's a weird, it's kind of a letter. It uses a base of E. Do you remember that number? We kind of mentioned it yesterday. Okay, so it's the same idea. That's what I'm doing. The log E is the natural log. All right, so let's get a few points here to start. So e to the -1, e to the 0, e to the 1. Okay, so e to the 0 is 1. giving me the coordinate 1, 0. Does anybody remember the value of e to 1 decimal place? 2.7. So 2.7 comma 1. And then why don't you practice in your calculator e to the negative 1 so that you make sure you know where your button is. And let me know if you can't find your button. And since this is graphing, I'm okay going to 1 decimal place, right? Because I'm not going to know your difference on your graph. So I'm just going with 0.4. Okay, so there's the 3 points on our original graph. Now, what do I have going on with my transformations? This is a and this is a C. So I'm going to go x plus 2 and negative y. X plus 2, negative y. So this will be 2.4 comma 1. This would be 3 comma 0, 4.7, negative 1. Do you know where your asymptote is going to end up? It's shifted. It's shifted to the right 2. Have you noticed that when you did exponentials, the asymptote only shifted if you had an up or down shift? And then these asymptotes only change if you have a left or right shift.